Hello, hello.
Hello.
How's it going, Robert?
It's going good, Paul. How are you?
I'm pretty good.
Are you in a spaceship?
This is the Rebel base from the most recent Star Wars movies.
Awesome.
I've been stepping up my Zoom background game.
I see that. Very nice. Very good. Um, yeah, I'll get with you later about attendance and stuff like that. But,
Okay. Yeah,
yep.
I got an email from. Well, I'll talk to you about it later.
Yep.
Hey, Mark.
Morning. What game's your background from?
This is Star Wars from like the. This is the Rebel base.
Oh, it is. Okay. I just didn't recognize it.
Yeah, I did find some other ones too. So I have some fresh ones for next week.
Okay.
Well, looks like it might just be the three of us today.
Yeah, this is.
So anyway, I'll just go ahead and get started. Yeah. Oh, there's Jacob. Hey, Jacob. No, not yet.
I'll text Krogan real fast.
Okay.
Hey, Mark.
Morning.
How are you?
Good. How about yourself?
I'm good. Hey, you've never responded to any of my emails. Is there a reason for that, or?
Let me look real fast.
That's okay. You don't have to. I'm just asking. This is really the only chance I really get to talk to you or communicate.
Oh, no,
with you.
there is no reason for that. I'll look and I'll actually shoot you my phone number too.
Appreciate that.
Yep.
Yeah, Mark's the only person that I've called that's actually answered the phone to talk over with with your voice.
Awesome.
Yeah, I'm a lot better at that.
Yeah, a lot of them don't want to talk on the phone. Much prefer text.
Yeah, this is an all new way of communicating for sure.
Oh yeah, it's new for everybody. All right, so yesterday we talked about how to create our assemblies. We talked about mates, and kind of the big takeaway yesterday, I think, with mates is they really behave just like sketch relations do. So that's kind of I think is a kind of a better way of, hold on just a second, I'm going to, there we go. So that's they work kind of the same way, right? So we are creating, in a sketch, we're creating relations from a line to a circle, right? So like a line being tangent to that circle, that's our relation. How long the line is, right? That's a relation. So in assemblies, we're basically doing the same thing. It's just instead of having a relation between two pieces of geometry, a circle or a line, or two lines or two circles or whatever that may be, now we're creating relationships, or mates is what they call it in SolidWorks, right? These mates are what our relationships are between our parts, right? So like that screw is concentric with the hole that it's in. The bottom of that screw is coincident, right? It's occupying the same plane as the bottom of the counterbore. So as a mechanically inclined people, we should be able to kind of look at these and kind of infer, well, I know how this part's going to go together, so I can kind of look at my my mates and hopefully figure that out. Another thing to think about with mates and relations is it really kind of ties in with GD&T, right? So a lot of the same terms that we're getting in GD&T, we're also going to have in mates and relations, right? Concentricity, coaxiality, flatness, parallelism, right? Those are all GD&T tolerancing I can't remember the name of it, but right, those are always tolerance and GD&T, or create tolerances. So, you know, that's kind of another way to think about it. So yesterday when we were going through here, one of the things we noticed, right, was my holes didn't quite line up correctly. Some, you know, they usually should if we create our geometry correctly, if we create our parts correctly, all of our holes should line up. But inevitably, something is not going to. So yesterday, you saw me. I like to create folders for my fasteners. This is more detail than I typically get into, or more folders. Like I have a folder with one screw in it. But this is just kind of illustrate how I like to do this, especially when you have assemblies with dozens or 100 fasteners in it, right? It can get out of hand pretty quickly. So obviously this helps me organize things, kind of helps me figure that out, but also this really comes in handy for things like what I'm about to do, right? So in order to evaluate the clearance between the holes in these two parts, I just clicked something, I don't know what I did. So in order to determine the clearance between these two parts, I have to look in this hole, right? I obviously can't in there. So because I added all these into one folder called fasteners, I can right click on this and just hide them all. Right. So instead, if I didn't do that, I would have to go in there and say, all right, well, these are my 832 buttonhead cap screws. I'm going to hide that guy. And I'm going to go ahead and hide that guy. Right. So just, it kind of adds, you know, speeds up the process a little bit when we have to do stuff like this. Also, sometimes you're not going to want your fasteners in your print, right? If you have an assembly print, you're not always going to want all the fasteners in there. So anyway, so as we can see from this, hopefully I'll get square on it. Right, my hole, my threaded hole does not match my clearance hole, and so I can use a different evaluate tools. I can see what the hole alignment is, but really one of the best tools to use for this is actually our measure tool. Also, one of the things I can look at here that really alarms me is, does anybody remember what this dash circle is around this hole? What does that represent? Anybody?
Isn't that the threads?
Yeah, so that's the major diameter on our threads, right? So that is a threaded hole. There's a threaded fastener that's going to go in there, and this hole is going to determine where this part is spaced on my assembly, right? So if this shaft is determining where this is located, I can't really push this down to get these lined up, or else I'm going to bind up on the shaft. And what really kind of alarms me is if I look at this, the threaded portion of this hole lines up or is almost tangent with the bottom of this that portion, right? So that is right off the bat, that scares me, but that's a red flag, because what's going to happen here is when I put a screw in here, my screw is going to be rubbing along the bottom of this if I make it to these dimensions, right? And I already looked. I looked yesterday after we got off and figured out exactly what was wrong. But one of the ways we can do that or figure out how misaligned these are is using our measuring tool, right? So our measuring tool is in our evaluate ribbon. So we go to measure, just up top here, right? Click measure, and then all I'm going to do is I'm going to select the inside of that cylinder and the inside of this cylinder. And right off the bat, right, we get pops up. So I am off in Z. Well, that's not very helpful, right? So, so Z is going to be going through this hole, right? So our Z-axis is coaxial with these two holes. So the axis of these two holes is actually our Z-axis. So I'm not sure what our 9 900 thousandths. Not really sure where that is coming from, but our delta Y is what we're seeing, right? So the delta Y is a 10, almost 11 thou that this hole is misaligned, right? And that kind of jives with what we're seeing because in a hole that small, I'm probably going to have 15 to 20 thou clearance. And if my hole is 10 thou off, well, if half of my clearance is gone in a 20 thou hole that has 20 thou clearance, well, I'm going to be rubbing the bottom of that. I'm going to be rubbing my threads, or cutting my threads across this, dragging my threads across this part. All right, so what's the problem there? Well, we kind of don't have to, but we can edit these parts in place. If I right click on this part, I can go to edit part, which is going to be in this right click menu, the fourth option, top row from the left. Open part is the first option in that top row, and that's typically what I do. Now I already have these open, so they open very quickly. All right, but if I look at my print, if I look at the print for this guy, all right, oh, wrong one. This is part 5. So when I look at my print, all 3 of these holes should be aligned, right? So I have big hole and 2 clearance holes, and they're all 400 thousandths from the top of that part. If I look at part number 2, right, we have the same thing. These holes should all be in alignment. So when I look at this guy, that's what I'm going to do. I'm just going to take my measure tool, and I'm going to click on these 2 cylinders. And so what I should be looking for is, if I look down in this bottom left corner, right, I have my gnomon. And so I know my misalignment as far as this part is concerned is going to be in Z, right? So if Z is misaligned, then it would be this part is the error, right? The error is in this part. Well, when I do this, I look at delta Z, and my delta Z is nothing, right? My delta X is going to be my center to center distance, but my delta Z for both of these is nothing. So I know that this part is correct. So I don't need to do anything with that guy. But if I go back to part number 2, right, which is going to be this guy. So if I open up part number 2, now I can do the same thing. I take my evaluate measure tool, measure the inside of that cylinder, measure the inside of that cylinder. Oops, I already had the face selected. So I measure the inside of that cylinder and the inside of that cylinder. And now I have a delta Y, right? So I should really only see a distance in one of these, right? A delta in one of these distance, or I'm sorry, 2 of these distances, because distance is also the delta. But delta X, Y, Z, I should really only see something in one of these because these are supposed to be aligned along my x-axis. Right? So my delta Y is the part that's wrong. So good news is I can just go into the hole wizard sketch for those holes. Right? So when we go to, we can do this a couple ways. If we select that hole in my feature manager, that hole gets highlighted. Or if I just know what hole that is, I can go over there and highlight it already. I'm just going to click on that first sketch underneath it, and I'm going to edit that sketch. And so what I tried to do is I tried to put a center line in the middle of this guy. As you can see, hopefully, right, there's the center point of that line, and there's my center line that's connecting these 2 holes. So what I can do is I'm just going to click both of these, and I'm going to select my midpoint and select that line, and I'm going to make those coincident. And that raises my center line that's determining where these holes are located. Right. And so now when I do a measure between those 2 holes, now I don't have anything. Now I don't have any delta Y, right? So now I know that these are, have a horizontal relation to each other, and that would be the ideal, is to create a horizontal relation between these 2 holes and this hole, but that doesn't really work because you have to select the middle of the hole, and that sometimes doesn't. Sometimes SolidWorks doesn't let you do that. Other times it does. It seems like when you use a cylinder like this, or cylindrical hole, it doesn't like it as much as if you had just geometry on there. So anyway, So we got that guy, and then I'm just going to save him and take it back to my original assembly. And so because I changed this, right, I changed this model outside this assembly, I'm going to get this message, right? Models contained with the assembly have changed. Would you like to rebuild the assembly? It didn't even let me answer it. So what it does is it uses this little stoplight up here. This is our rebuild button. So if I make a change in here, it's not going to make that change automatically until I click that rebuild button. But now, hopefully you can see, my holes are lined up much, much nicer. I still might have some sort of weird error. No, cylinders are coaxial, right? So now I know those are exactly where I want them to be. So I can turn my fasteners back on and I win. All right, so that's just kind of one of the ways we can troubleshoot our hole locations. Like I said before, that's really one of the big strengths of CAD is we can look at these models and figure this out before I make it, right? So say I draw this up and I forget to put that dimension on there or whatever, and they make this part, or I use a CAD, a CAM package, some CAM software, and don't really measure my original part. Well, then I put this all together, and that's going to be a problem, right? So I'm either going to be looking at making a new part, drilling these holes out bigger. I'm going to have to make some sort of correction, most likely. Maybe those screws would fit in there just fine, maybe not, but don't want to play that game. So, does that make sense for everybody?
Yeah.
Okay. So our next step is we got this assembly, and now we need to create, well, we don't need to create, but I like to create prints of my assemblies, right? Because one of the problems, and we run into this in this class, right, is you have an assembly that has 5, 6 parts in it and no assembly picture. It can be kind of hard to figure out how to put it together. So in this setting, I like to include an assembly drawing, but I really like to do that anytime I'm going to be handing this off, right? So anytime I'm going to be handing this off to somebody, I like to put some sort of assembly in there if they think, or an assembly print is very, very minimum, and some other features that are also helpful. Big reason I like to do this is because I can create a bill of materials. So bill of materials is just going to be a print that lists all of the different parts that are in here. So sure you've seen these before, a schematics drawing or something that has, you buy a vacuum cleaner or whatever, and in the back of the manual has a blow up of the entire vacuum cleaner. It has all the sub-assemblies and all the parts labeled and all that stuff. So we're going to kind of go over how to do some of that. Nothing like we won't be doing a vacuum cleaner, but we will be doing this guy. So to create oops, wrong button. So in order to create a drawing of this, it's just like creating a drawing of anything else. We're just going to make drawing from part assembly. And I'm not going to use either of these templates. I'm just going to use my generic one. So we're going to do landscape. And so there we are. So, right off the bat, I like to kind of just do a three view. Oops, I hit that. All right, so pretty straightforward, but this might look better if this was laying down. So I'm going to go ahead and rotate that. All right, so I'm just going to right click in that view, zoom, pan, rotate view. I'm just going to turn it 90 degrees. Oops, 90 degrees. Oh, come on. There we go. We'll close, and there we go. So I kind of like that. I think that kind of works a little better. If we wanted, we could add a 4th view. Kind of gives us some more information. All right, so this would be just kind of a general outline or layout of what this assembly is. But in this, what I also like to include is a bill of materials and an exploded view of this, right? Because this kind of tells us what this is going to look like when all of our parts are together, but it doesn't really tell us much about how this actually goes together. Before I do that, I'm just going to, because I'm nitpicky and this is always annoys me, I'm just going to change that. There we go. Okay. That makes me feel better. All right. So from here, if I wanted to create a new drawing, right, I would create well, there's a couple different ways. I can create a new file, or if you look down in the bottom left, right, we have sheet 1. We can actually create many sheets of this one blueprint. And this is nice because what we can do is, just like in Excel, we can, or many other programs, we can create new sheets and then we can select all of them for printing or one for printing or whatever. So because I already made some small changes on here, I'm just going to go ahead and do a copy paste. So if I right click and select copy, and then I just right click that first one again and hit paste, it's going to ask me, do I want to paste this before or after selected or move to the end? I'm just going to do after selected. All right. So now I have basically the same thing, but I'm going to just delete my views out of it. It's just kind of easier to do it this way than it's easier to delete those views than it is to go in your title block and re-edit that. So from here, what I'm going to do is I'm just going to put in my assembly view, and I'm going to go up to here to tables. So when I click on tables, there are lots of different tables we can do. We'll talk about some of these. General table is just, if you know what information you're going to put in there, that would be, that'd be your table. So it's just going to create a blank, like a blank Excel spreadsheet. A whole table is going to list whole locations on our parts. Not super useful for any of the parts we have, but like I said, we will actually go over that. Bill of materials is what we're going to do. And we have revision tables. So if this is a part that has been revised a lot, we can create a revision table up here, right? So a revision table says, hey, in 2018 or April 2018, we changed this feature. So, we changed this feature, and this is a very, very brief discussion of what it is. And what that allows you to do is, say you have a independent contractor that makes parts for you. So like this used to happen to us at Sanks, right? So we were an independent contractor and we would make parts for these other companies. And sometimes they would make revisions to these parts. Well, lots of times we would keep our blueprints there. So we had file cabinets full of blueprints from different companies. Most of them, if they did care that we were keeping them, Sanks didn't care. But anyway, so sometimes you go in that blueprint cabinet and pull out a blueprint and it's 15 years old. Well, there might have been 3 or 4 revisions to that blueprint, and now you're making the part wrong because you grabbed the wrong print. So this kind of allows people to know what changes have been made, so they can get rid of old prints or put annotations on their old prints. Weld, bend, and punch tables, we're not doing much fabrication here, so we're not really worried about that. So we're going to do bill of materials, and it's going to ask me, select a drawing view to specify the model for creating a bill of materials. So all I'm going to do is I'm just going to select that view right there, right? So then we get all sorts of different options over here, right? So bill of material type, top level, parts only, indented. So top level is going to list every single part. Parts only is only going to list, I believe, the part files. I think it would omit our fasteners and that sort of thing. So item numbers, right? So it's going to number every part in here automatically. And then then we have some other options here, right? So part configuration grouping, display configurations of the same part as separate items. So if we have two fasteners that are the exact same size, it will list both of those fasteners as two separate items, right? So we don't really want that. So we're going to display all configurations of the same part as one item. Display configurations with the same name as what item? Well, we're going to skip that. And that will be good for us. From here, we can change borders and that sort of stuff, but I'm not really worried about that. And so what's going to happen is we pop that up, and this is what we end up with. All right, so this is a list of all the parts in here. So one of the, that's actually incorrect. Huh. Why does it have all those as number 10s, I wonder? Huh, that is interesting. I've never had that happen. So we have, these are quarter 20s. So we have 1, 2, 3, 4, 5, 6 quarter 20s in there. And it's counting 6 of them as a number 10. At least I'm pretty sure they're number 10s, or a quarter inch. Yeah, those are quarter 20s. So that's fun. All right, so yeah, obviously this doesn't always work out perfectly, but what we can do is we can kind of modify this so it's better for us. Right off the bat, looking at this, you might go, well, that description column is pretty useless, right? There's no information in there. In this example, our part number, we could put a MSC part number or McMaster car part number, or whatever your supplier is. But I just put the fastener size in there. So what we're going to do is we're just going to delete that column. And now we have a kind of a more streamlined version. We can still change column width. We can change column height or row height and all that. So what I'm going to do here is I'm going to actually insert a new column, or I'm sorry, row. And so I'm just going to, oops. So I double clicked in there, right? If I just double click in there, under normal circumstances, let me edit it, but now I'm going to get a warning message. So if this is kind of the quick and easy way to fix this, what this will not do is maintain a link to the original part file. So this is done. I know I'm not going to need it to revise this. So I'm just going to continue editing the cell, because what's going to happen is it's going to lose any sort of connection with this part. And those were 1¼ by 3/4, I believe, socketed cap screws. And I know there were 6 of them in there. There we go. And then that's just going to be 10. No, come on, don't show again. So those are just going to be 1032s, 1032, not 110 32s. Those are much bigger. Those will be too big. 1032 by, I believe they were 1/2 inch. And that was a socket head cap screw. No, that's why it linked them all together. It's because those were both socket head cap screws probably. And these are set screw. That's a set screw, and those are button head cap screws. So that's probably why. So it's gonna be 832 by, well, I think it was a 1/2 inch button head cap screw, VHCS. And then we have, those are 832 set screws. And those were 1/4 inch. just going to change that to 1. Don't show that again. There we go. So that's more representative of what we have. Sometimes it's nice to blow that up also, make it a little bigger. All right, so now we have a multi-view print, right? We have a bill of materials. And so now we're going to create an exploded assembly. So again, I'm just going to take my original, copy, and then paste. I'm going to move this to the end. And so we can also rename these. So, if I wanted to rename that, I could just say view 1, because that's so much more descriptive than sheet 1. And then this might be BOM, BOM, bill of materials. And then this one, let's say this is going to be explode. All right, so we have our, actually, let's rename that. Oh, no, I didn't want to delete that. Oh, well. Oops. Well, good thing I copied it, right? So I'm just going to copy and paste. Move before. Oh, it didn't. All right, so we'll rename this for view. All right, we have 4 views on there, so it's 4 views. So in the explode, we actually don't do the explode in a drawing. Before we can actually make the exploded view in a drawing, we have to make an exploded view in our part, or sorry, in our assembly. So how do we do that? Pretty straightforward. So one of the things to keep in mind with this is this doesn't actually save a view. So this was kind of a tough thing for me to kind of wrap my head around when I first started with it, or didn't first start with this, but when I first started making exploded views. So with this, I used to make, you make an exploded view and it doesn't actually save anything around here. So the tricky part of that is so you make this exploded view and then you're like, well, how in the hell do I display that? Well, it's actually pretty straightforward and we will get to it in a second. But all right, let's first do our exploded view. So what that's going to do is it's going to allow me to select different parts at a time. Right, so what I'm going to do is kind of make this, since this part connects vertically onto part number 1 and this guy slides out of part number 1, I'm going to use part number 1 as my base. So part number 1 is the only one that I'm not going to move. So I'm just going to select that guy, and basically how you do this is you kind of just drag this around. So I'm going to drag this up. I'm going to drag it up pretty far because I want to pull this screw out of here. All right, that screw is kind of hidden in this in this assembly. So somebody putting this together might be easy to miss. Well, if I put that in between these two parts, it's going to be a little bit harder. So I'm probably put that guy up just a little too high. So I'm going to move him down just a little bit. And then I'm going to move these guys up. Oops. No. Ah, damn it. All right, so my exploded view reset. Because I pushed the wrong button. So I'm going to select all 4 of these screws. Just going to drag. What in the heck is that? So I'm just going to delete that step. man, what is going on here? It just really does not want me to select these guys. There we go. Okay. So now we're just going to drag all of those up. Why are those not going? Why are those not locking together?
Here,
Here, I'm going to try this again. All right. One more time. So I think it might have been this auto space components on drag. There we go. All right, so I'm going to put those above that hole. Move him down a little bit. Get a little out of hand there. All right, so then, all right, we got these two screws here. And we're just going to pull those out. So as you can see, we're just kind of going around selecting all these different components and dragging them out. So if I drag this out, it would be basically these three parts. Oh, forgot my set screws. So oh, Christ. This is the most frustrating part about the explode. So you can't hit escape. You can't hit escape during explode because what it will do is it will just get rid of everything you just did. So that's why you've got to see me do this 3 times, because I'm like an escape junkie here. Apparently, I just can't stop, guys. Can't stop hitting escape. Gonna get clean one of these days. Don't worry. All right, so let's try that again. We're gonna pull him up. There we go. We're gonna get these guys out. Now this time I won't forget the set screws. Now we're just gonna drag him out. So I'm just gonna drag him so he's barely out of this part, because this is gonna get out of hand if I don't do that. I'm gonna select these 2 or 3 parts. And then I'll select these 2 guys. And then he goes in between. And that's gonna come down. All right, so that is basically how these parts go together. So I'm going to click OK. And now I have created an exploded view. So if I hit exploded view again, it's going to get rid of that, right? So from here, when we go to our print, all I'm going to do, so I have my empty space here. I'm just going to regenerate that. So I made a bunch of changes to my assembly, and when I did that, my views were not visible. If you click this little refresh button, it will reload. Basically what it does is it rebuilds your assembly, and then you can load it in there. All right, so oops, not that one. So I'm going to do my right view. I'm going to get rid of that guy, so that's not a very good view. All right, so now, how do I get my exploded view into my assembly or into this drawing? And it's really up here at the very top, show an exploded or model break state. So when I do that, it's going to give me a couple choices, right? So every time I did that, I guess I could have gone back in and edited them. But basically what's going to happen is going to have your exploded view. And now, this is kind of cool, I can do projected exploded views. So I could do, I could have that and then have an ISO model outside of it. Or I could say, hey, I think that ISO model is way clearer than this front view or side view. So I'm just going to have that in there only. Right. So that's pretty cool. But one of the things we can also do is, so say I wanted to do this and actually have my bill of materials on there. So I could take that bill of materials table and just hit Control C or do a right click copy. And going back over here and then paste it. Oh, apparently I can't. What? Huh. What the heck? Let's see if I can do it this way. Control C, Control V. Nope. Okay. Well, I guess we'd have to create a whole new bill of materials. But what we can also do is do auto balloon. So right now, like in our bill of materials, right, we have this bill of materials here. I guess I could also just say that's an exploded view. Yeah, that might be easier. So I have my bill of materials here, but I don't really know which of these parts is which. So if I select this view and then do auto balloon, what it's going to do is it's going to go in and automatically label all these parts for me, or at least the ones I can see in this view. If I go to my explode view and I do the same thing, let's see what happens. Yeah, so since we have more of these parts visible in here, it's going to have more of them in there. Oh, come on. And so then we can adjust them. These work just like all of our other callouts. We can move this around. You can see that when I take this pointer off of this part, it loses this number. And when I put it back on there, it gets it back. So if you're dragging around, you're like, why does it have this weird question mark in there? It's probably because the end of your pointer is off of your part. You can move it around, but it still needs to be touching the part. All right. So you can probably imagine that this is pretty useful in when creating schematics. Kind of really helps with your keeping things organized and straight. I just like to kind of bring these in a little bit. So there we go. So, right, today we went over how to troubleshoot our hole alignments, right? Because I goofed that up yesterday, didn't draw my part correctly. And that's going to happen, right? So you're going to, we've seen it already. Solidworks will infer relations between geometry as you draw it, but it won't necessarily save that geometry. So, you might think that you're drawing this line, vertically or in line with another line or whatever, but then you change something in that model and it will change that geometry, right? So nothing is locked in until you lock it in. And so that's what happened with me. I made that line and thought I had it centered on that hole, but apparently I didn't. So we talked about how to troubleshoot, how to change hole alignment and location. how to use that evaluate and measure tool. Talked about how to create an exploded view, right? So exploded view is pretty straightforward. Most confusing part of that, at least in my experience, is is you have to create your exploded view in your model, right? And the cool part is, at least as far as I know, I don't know where you get to all the different exploded views that are already created in here. Don't know. Is it in annotations? Nope. Don't know where it is. So if you can find that, that'd be cool. I mean, yeah, that'd be awesome. So we have, we created an exploded view. We're basically just saving that as a configuration of that part file. And then when we create a drawing, we can designate that drawing as an exploded view and it will automatically change it, right? And that exploded view is just in that view properties box is just that first check box up there. All right, then we went over bill of materials as well, how to create a bill of materials table. It's pretty straightforward. Any questions on anything? Any problems? Any issues?
I have a question for you, Mr. Pakanowski. Do you guys know anything about the plan for graduation yet?
Oh, he's gone. We don't. He might know something that I don't, but at this point, they are not sure what they're going to do for graduation. We have not heard anything you have not heard, or at least I have not heard anything you have not heard. I mean, realistically, with how things are looking out there, even if I'd be very surprised if anything happened this summer, to be honest, unless they decide to do some sort of virtual graduation. But as far as like getting 1,000 people in a stadium,
I more meant like just with the end of classes part.
Oh, okay. Yeah, I don't think that they've set any sort of timeline on that, but yeah, I mean, we'd probably be looking at having, well, there's 9 of you, so I don't think that would probably be that big of an issue, but I don't know. There'd probably be some sort of spacing out or something like that. But yeah, as far as like having something really set in stone, we don't have anything. The biggest thing that they're waiting on there is city of St. Louis, because Rankin's in the city, we have to go by the city of St. Louis orders.
Yeah.
So, and I have a feeling schools are not going to be one of the first things open back up.
True.
But I don't know. I guess we will see.
Have you gotten any communication on that computer or anything like that?
I got an email. Let me check. I got an email yesterday.
I haven't gotten anything.
From Paris Reese saying thanks. I will reach out to him. Thank you all again. And that was yesterday at 10 a.m.
Okay.
So, do you have her email?
Yeah, I have her contact information. I'll shoot her an email.
Yeah, why don't you shoot her an email? Has Jason talked to you? Jason Hug?
I believe so.
Okay.
I believe that was his name.
He's the IT guy.
Okay.
He would probably be the best person to contact because he's actually going to be the one doing your computer and setting it up. So he would have the best idea. He's the one that said he would have it. He's the one that said we can have it ready after 11:30 today. He said this. He said this yesterday, but he said he would have it available to pick up after 11:30 tomorrow. So that would be today. So I would probably give him, shoot him an email. He's pretty quick to respond usually.
Okay.
If you don't have his contact, it's JAHug@Rankin.
Okay, HUGG or HUG?
HUG.
Gotcha.
Jahug. Jahug@Rankin. Yeah, but I would probably give him a call or email or whatever. They'll probably go a little quicker than going through Paris or Mila or whoever.
Understood.
So anything else?
Nope.
All right. Well, have a great weekend, guys.
You too.
All right.
Too.
Take it
Bye.
easy. Bye.